Hey class, it's Philip Seagraves getting you guys ready for quiz number 3. This is part of the Managerial Sciences 3100. We are closing in on the end of the semester, and now we have our final test on decision analysis. And in this case, we're going to walk through several questions, 9 to be exact, that are going to be coming up for quiz 3. And these are very, very similar, the same types of questions you should expect for the quiz, and we'll see similar ones on the final as well. So we're going to start off with this first one. As you see here, we have a basic decision tree, and we've been asked on this decision tree, should we make or buy? What is the expected return? And this is all in dollars, and the objective is to maximize our expected return. So solving a decision tree like this, we're simply going to work from right to left, and we're going to use the probabilities which are here, multiply those by the payoffs, multiply the probabilities times the payoff, add those up, and then we are going to put a value on each of these decisions, the make or buy decision, and the largest one will flow all the way back to the beginning of the decision tree, and that will be the one that we ultimately choose. So let's take a look at this one. We have a 35% probability of 103. So let's say 0.35 times 103. Actually, I believe that was minus 103. And we have a 65% probability of 600. 0.65 times 600. And at the bottom of our tree, we had 35 of negative 240. 0.35 times 240. And obviously, you could do this with pencil and paper. 65 times 900. 0.65 times 900. So this is a 35% chance of making negative 103, 65% chance of making 600, 35% chance of making 240, and a 65% chance of making 900. I'm going to go ahead and put an equals in front of these so that Excel will do the math now that we have seen them. And that way you can see what's happening here. And then I'm going to add those up. All right, now if I sum each of these, we'll put the sum right here. So this branch of the tree is worth $353.95. And this branch of the tree down here is worth $669. So if we have a 35% chance of making this value and a 65% chance of making this value, a 35% and a 65% chance, what should we do? In this case, oh, there's a problem there. That should be a negative. I knew this didn't make sense. There we go. What we have here is a 501 versus 353.95. So in decision tree, we're going to choose the branch of the tree. We're going to get rid of the one with the smallest, so we won't use this branch at all, and we will go here. So 501 is going to be our expected value, and that's going to be on the buy decision. So the solution to this would be buy and 501. All right, let's move on to the next one. The next one is our selling price per unit is 25, variable cost is 5, salvage value is 2, cost of lost sales is 2. Now we have to find the profit when 40 units are produced and the state of nature is of demand of 65. And we do not include fixed costs here. So we'll copy this, jump over here to Excel again. And now we've got the question over here so we can remember what it was. So to figure out our profits in this case, we're going to come up with our revenue, which is 25 times 40. And then we're going to subtract our variable cost, which was $5 times the 40 that we sold. And now we didn't make enough, so we're going to have lost sales of 20. So we're going to have 2, which is our lost sales, times 20. So we have 24 times 40 is our revenue, and our variable cost is -5 times 40, and our lost sales is a -2 times our 20. So our answer in this case is going to be 720. So again, we have, there's a problem there. That should have been 25. I didn't think the math worked out right. 760. There's our answer. A little typo slip of the wrist there. So our answer in this case is 760. Okay, let's go back to our next question. Number 3. Using a decision tree, it's found that the expected monetary value of market research survey is $40,000. Expected monetary value with no survey is $25,000. So with the survey, we can make 40. Without it, we make 25. What's the most we would pay for the survey? Well, in this case, we don't even need Excel or calculator. We just figure the difference between these two values. 25,000. If we buy the survey, we can make 40. So how much would I pay? The most I would pay would be the difference between these two values, or 15,000. All right, the next one is our maxi-min criteria. Maxi-min, we are going to choose the conservative strategy, the one where we lose the least amount of money, the least we could, the best scenario if the worst thing happens. So in this state of nature, these are our potential options. So the worst case scenario is 20. In this state of nature, the worst case scenario is 2. There's several values of 2. In this state of nature, the worst case is 90. So which of those worst cases is the best? In this case, it's 90. So in a maxi-min strategy, our choice would be 90. Maxi-max, we're going to choose the strategy with the highest possible outcome, which is going to be A. The biggest value in the whole table is over here, and that is A. All right, let's go on to question number 5. Question number 5 is pretty straightforward. We want to find the expected value of the sample information down here. In this case, our sample is a survey, and we see a big decision tree here with 2 main branches. One is with a survey up here, all of our expected payoffs, states of nature, and in this case, these pound symbols in here indicate that's the lower value. And we are going to work our way back through the strategy over here, and we find that if we conduct the survey, our expected payoff is $29.45. If we don't conduct the survey, our expected payoff is $28.45. And we really don't need to solve all of these other pieces of the decision tree. All we need to understand is that what we would pay for the survey is the difference between what we would make with the survey and what we would make without the survey. In this case, it's $100 or $100. So we know that the value of the survey, or the expected value of sample information, the most we would pay for the survey, is $100.